Oh my god, I forgot to remove the overlay. Sorry. Um, hey, good night. Well, for me, it's good night or good morning. It depends on which time zone you are. Again, great thing about having a global community. It's all the sharing and the culture and etc. Bad thing is you can never say good morning to anyone or good night in this case because you don't know, right? So I see some comments here about our great hacker is Sparky Circuit student. Whoa, time to launch. Hi Alberto, hello everyone. Right on. I hope you're excited about this session. I am too. Fun size 19, it says hello, and Portnap says hola. Gaming Fio says hello with a lot of letters. So I hope we got our emotions on the top, and we can start this session. Let's do first a little recap of what we seen so far. For example, for you that means part one, two, and three. And don't worry, you can always watch the recap here. Sorry, the recording here on YouTube or you're on Twitch. You can always watch it on Twitch too, but I think it's easier to find the specific video you're looking for on YouTube. If someone can help me share the link here, I'll be glad. Meanwhile, I'll be talking about these recap. Yeah, amazing. I know you won't fail me. Thanks, Sparky Circuit student. Here's the link. For example, the YouTube Majorly Hacking Streams, and you can find the missing parts one, two, and three. And in this part, uh, stay here. You don't need them. You can always watch these again. Don't worry. But in these parts, the first part in particular, we talked about the history of JavaScript. We talk about how it works, like more internally, what is the engines, etc. And most important, we started creating our mental model or for JavaScript. And I mention this every episode, but the mental model helps you a lot to understand what's happening in code, not only for JavaScript, but this mental model has to change depending on the language you're doing. And I think was the previous session, the part three, I mentioned these about the example of the natural languages. I mean Spanish, English, etc. That actually they change the way you think because you can think in Spanish or you can think in English, you can think in French, and you need to change to think different because the way you communicate it's not the same in the languages of the programming, right? You can think the same in Python as you think in JavaScript. There's a computational way of thinking for sure, yes. The way we instruct our brain to process these algorithms and then try to replicate them on the computer, it's like the baseline, yeah, for sure, equal to the natural languages. um, but for JavaScript, as we were exploring, for example, having the idea of our code being a planet and having these parts of our code like living inside our planet and the variables as not values but wires that point or connect these other bodies in the universe of JavaScript, being these other bodies primitive values or objects. Well, that's a complete mental model that I wanted for you to build. I took this mental model from the great Dan Abramov, and it's been pretty useful in my whole career. Um, well, that was for part one. In part two, we checked more in depth the objects, because in this first part we only talk about like the theoretical stuff and primitive values and the mental model, and in the second part we checked and encode we review again the primitive values but in code, and we checked about these functions, the difference between the variables, how you declare them, let, const, bar, arrow functions, regular functions, uh, properties inside the methods, properties inside the objects, methods inside, which are functions inside the objects. What else we checked on session two? Well, that far. So in part three, we review um, the prototypes. The what else we checked? Let me remember. Um, Prototypes, the methods, well, talking about these prototypes, the all the objects seems all that all things in JavaScript are objects except for the primitive values. Um, some of these objects heritage methods. For example, the arrays, the object indeed, they have specific methods that can create and do stuff in JavaScript. And well, I don't remember what else, but you can watch part three. And in this part four, I would like to recall to the page we were checking about JavaScript, the description. Let me start sharing my screen to talk about a really, really important part that we are missing on JavaScript. Let me start sharing my screen. Okay, you should see it now. We talk about JavaScript, lightweight. We talk about this interpreted stuff or just-in-time compiled stuff. I think we checked that on part three. Okay. Um, First class function, meaning that we can do both functional programming but also object-oriented programming. While it's most well known as a script language for web pages, that's not the only thing for JavaScript. I mean, it was born as a script language for web pages, but thanks to what I did. Thanks to Node, these help us to run JavaScript wherever we want, because Node it's the runtime environment for JavaScript containing the engines. V8, I think. Well, no, I'm almost sure that V8 is the one that Node uses. JavaScript is a prototype-based multi-paradigm. This part, single-threaded language. What does that mean? Well, it means that despite our languages, we can only do one thing in JavaScript, which led us to the thing that you probably heard that JavaScript is asynchronous language, meaning that we can start from one line and going back, start an action here. And if these were multiple thread languages, multiple things can happen at a time. But JavaScript doesn't work like that. What actually happens is that if we want to start an action that is asynchronous, meaning we don't know when it's gonna end, but we need to wait for that value, we need to pause execution until that value returns. And you're probably thinking that's insane. That can reduce performance a lot in a language, right? Well, JavaScript has a beautiful thing to solve this that's called the event loop. And we are going to talk about that But first, let's explore the ways how we resolve asynchronicity here on JavaScript. Well, what else about this page? Include runtime, objects, utilities, to string, the standard. We talk about the standard in part one too. Um, mm, mm, mm. Okay, great. So let's open Hyper. Global Hack Week, and this is season launch, and this will be JavaScript, right? So here's my Visual Studio Code, and previous session we created uh, a, a file called async. So we're ready now. Let me just make this bigger so you can watch how this works. Okay, I hope that's big enough. If you want it bigger, just tell me, right? Starting with callbacks, then going to promises, and the last thing will be a single way, finishing with, well, this observable. It's a thing that makes RxJS. I'm not sure what I think about this yet, even though I've been using that for 3 years. But we'll leave it here for callbacks, promises, and the single wait, since that's the only thing that the current version of ECMAScript supports natively. Oh, right. So let's start with the callbacks. And I just need a second to do a thing. Give me a second. Okay. I see that my screen is freezing, so I would like to ask you that if at some point you stop hearing me well, or you just see my screen but it's freeze, or my camera or whatever, just please let me know. Um, I need to restart here. Okay, everything is fine now. I'd like to share with you a little image that explains better what I was mentioning about synchronicity. Here's the image. So, a synchronous single thread of control will look like this, meaning we just have one line going up. Synchronous two threads or multiple threads of control will mean something like this. What we have is asynchronous here, single thread of control, looking in a graphical way like this. My video and audio have been smoothly clear, so amazing. I think that should be my monitor refresh. Um, okay, starting with callbacks. Imagine you're working with a thing that you need to wait. In JavaScript, since this is focused for web developing, this could mean an API call, a request via internet that you want data from it, right? Um, well, in this case, we could make a call to an API, and etc. But a quick way to mock this, it's using a function that it's built in on JavaScript that it's called set timeout. Set timeout, and actually, I have to spoil you because We've been using callbacks since the previous examples. Let me look for a way here. For example, for each, what we pass here, it's a function as a parameter for this other function. So callback can be described just like that. When you say to a function, when you complete yourself, then run this function. That will mean when something happens, I want to trigger this other action because I don't know when it's going to happen, right? So let's return here to the same timeout. Well, same thing it's happening here, except that in this case, we are not having this function from an object that is existing. This is not a method like the for each. This is a built-in function for JavaScript, right? So we pass this, and I can make this other way for you to be simpler. For example, we can create a function called callback. I'm going to call it our callback function. And what this is going to do, it's exactly this. This is going to say callback function called, right? So for set timeout, we set its first argument. Sorry, let me drink some water. The the callback function. They call it here the handler or callback function, and then a second parameter, the timeout in milliseconds. So, for example, if we want to wait 3 seconds, this is going to be 3,000, right? So let's run this. We run it, and after those 3 seconds, we receive our callback function. It's hard to tell because this is a in, and you probably were thinking like, I don't know in which moment I were to hit enter. So I'm going to add another console into log that it's called start, and let's look what happened when we add a console dot log that it's end, right? So node async again. Look, in this moment we receive start and end first, even though set timeout function was called before the console log. Why is that happening? Well, returning to our mental model and what's happening here line by line, first we start the program. This called the console log. This is displayed here. Then we call out send timeout and we say, okay, in 3 seconds, this is going to fulfill. When this fulfill happens, what you're going to do is execute this function. And take attention to this. We are not passing the function or we are not executing this function here. We are not doing this execution. If we were doing that, the output will be different. Actually, this is an error because the callback argument must be of the function type. Here we are executing it, so the output will be another function. Here we can return another function saying like This is the return function for calling the callback function, right? So let's run this. And in this case, we might think this worked fine, but actually, this is what I was saying. Here we call the console log, so we display start. Here we say after 3 seconds passes, call this function, but not the function that it's called or callback function. The function that it's returning this call. So that's why we are returning here a function, an anonymous function, I have to say, because this is a async one, right? Sorry, an async one, an arrow function anonymously. So we are going to remove this, and here put attention on not executing the function, but pass the reference as the argument. So in this case, the set timeout will know that when that 3 seconds happen, this is the function that it must be called. I know it might seems unclear. This is very important. So that's why I ask you that if you didn't understand, please let me know here in comments, and I will try to explain it again. I will expand this to to make if the example is clear. Remember, this is the reference to a function, and a function can be declared here as the function reserved word, or like this, to our callback function, like this, right? So let me another, like this. So here we're storing the reference to this function, and we can pass this to the parameter as a parameter, and the output. Well, actually, this is a problem. Cannot access before initialization. Yeah, sorry. Uh, yeah, the thing here is okay. Okay, now it works. Remember what we talked about hosting? Well, in this case, we needed that for resolving this because I used let, right? Again, everything it's fitting in JavaScript universe. Well, well. This may be complicated, so that's why many people, instead of passing the reference to the function, explicitly write the function as an anonymous one, right? And that's the same. Here we are declaring an anonymous function, and here we are calling a named function, and the name is our callback function. So I hope that's clear. I see no comments, so hope that's clear, and hope the stream is going well. But still, we have start, end, and the callback function. Now we understand what's happening here, but why then end its call before this callback? Well, I mentioned that this is going to be asynchronous. So JavaScript says show must go on, right? So if show must go on, you need to do the rest of the file, and when you're ready, when everything happened, you can come back and say, oh yeah, your result is ready. Like, hey, I got what you asked for. Here it is. In this case, start, end, and the callback function. If we don't want this, and if we want everything to go in a single line, in without these breakpoints, we need to do a thing called nesting these callbacks, right? So I have an example here. In this case, I'm going to do the, give me a second. Hell. To, my internet is kind of slow, so give me a second. You have time then to process this. Mm, okay, so after this is done, we say here we call, we can say function with the name another callback function, and we don't pass anything as a parameter. We say here and we call here another callback function. So let's see how this behaves. Start, then the callback function it's called, the end. But let's imagine that, well, in this case, the calling of this other callback function was immediately, right? But let's imagine that we want here another, well, remember, say timeout, it's only a way to mock the calling of our resource, that it's going to be async, that it doesn't execute immediately, and we don't know when it's going to return its value. Here I'm saying the timeout will be 3 seconds, but it could be even 5 seconds, right? So that's it. So here, and we call it again. So we have start, 3 seconds later, we have the callback function it's called, and 3 seconds, 5 seconds later, we have end, and the program is done. So this is how we can go in single thread without the breakpoints in our timeline, right? Because otherwise, if we give this outside the callback function, well, we know that we have a start and end, that then whatever. So that doesn't work. That doesn't make sense. And it's the last thing that should be displayed. But let's say this is not end. Let's say we want another callback function. It's called, and we have another function that it's our last callback function, and this now has the end. And same as before, we have the same timeout callback, last callback function in just 2 seconds. So let's run this and look what is happening. Start, callback function it's called, another callback function should be called, yeah, and then the end, right? And program it's done. This looks like a complicated way we are calling callbacks inside callbacks, and I kind of manage it to look not so bad. But I want you to take a look at what this could look like. It will be the same behavior. Let me comment just all of this. And for aesthetic reasons and for you to understand this in a more clear way, I use them in a separate function. But lots of people tend to do things like this. Here, console.log, first callback function is called. Then set timeout, will then 500, then console.log, second call function is called. Then here we can call another, and then this. So we have one. No, I'm missing. I have five of this, and I have only two of this, so I'm missing. Yeah, here, like this. And I'm just calling end. And I am going to run this. Start. First callback function, it's called. Second callback function, it's called. Then third callback function, it's called. And then the end, right? And program, it's done. What this is, um, it's called the callback hell, and looks in funny ways like this. For example, the Pyramid of Doom. You can add a Ryu here, and this looks like a legit example because let's take a look at this. Load link is an async function. Uh, Call structure brand like you started. Yeah, I know. I did it because I know this is simpler to understand than this. And actually, again, this is a problem because this looks silly, like why you should call timeouts and timeouts and timeouts. But these examples are true. If you want to load a link, but then that it's a dependency of the next one you want to load because you need to wait for the result, and then the next one, and then the next one, and then the next one. Well, this is the callback hell. Another one, well, this is a generic example too because they are called just functions. But for example, well, there are no more examples like this because at some point we as JavaScript developers realize that this is a problem and this is bad practice and this is not what we should be doing anymore. A way we can sort it, it's using these kind of structures, but again, you will need to keep track of here, and you can say, hey, this goes to another one, and then this goes to another one, and then this goes to that's all right. um, I mean, promises, sorry, callbacks are not bad. Callbacks are a great way to program, and that this is one of the greatest things of JavaScript when you use it the correct way. The correct way could look like this. The incorrect way look like this. For example, here the callback we are doing for each array, for each method, it's just the way it is. Like this is a very common scenario in JavaScript, and this is completely fine. Don't be afraid of callbacks. Callbacks are your friends. So let me comment this. What comes next are promises. Promises. It's a way to say like in a very literal sense, I promise that I will be doing this. Just wait for me. Like I promise I'll be returning this value. So wait for me. So let's start with this. How we declare a promise. For example, let um, promise equal new promise. Actually, thanks, Copilot. But in this case, no. First, let me do let a promise equal promise dot resolve promise resolved, and console log promise and type of a promise. I thought I saw some comments, but just this one code structure. But I'd like to start the other way. Hmm. Let's call this start. The promise we have is a promise of type object, and the status of the promise it's resolved. What happened here? I promise dot then console log data. I want you to check something. Promise result was never displayed on the console, even though we were doing console log of this promise. The promise, it's a promise status that was resolved, but we want the data that that promise is storing, and for that we use, looks familiar, a callback function. So when this promise is resolved, that happens with the dot then statement. Here, for example, it's a method that says attaches the callbacks for the resolution or rejection of a promise. We are saying here that this promise will be resolved because we're resolving it. And I'm going to explain that. Just give me a second. Just before that happens about the resolve and reject, let's do this then to understand or to see now the promise resolved um, how to say it? A string, sorry, a string for this. So it started, it was console logged first the promise type of, and then, well, it can be massive because of the then word, but after the resolution of this was displayed. And you can think why that happened. Well, it doesn't matter that this promise was resolved immediately. 1 millisecond, half millisecond, 0.0000001 millisecond after it was declared. It doesn't matter. It's still a promise. And since it is a promise, it is asynchronous code. It will be take off from our timeline. JavaScript will resolve everything else, and until every synchronous code was resolved on JavaScript, then we can turn back and say what's the resolution of all the asynchronous code we added. So that's why I can add here console.log, not saying end, but saying this is going to be printed first. Even we're saying then here. Remember, it doesn't matter here that we are saying console log in a line before this one, because this is going to be then. This is going to be a callback function. This is going to be added or executed when all synchronous code is done. So another thing interesting here is the promise resolve status. We will explore that. So start, this is going to be print first, then this one, and at the very last, this example. Let's do then the new the promise with this new promise statement. And we are passing a resolve a reject value that this will receive, right? I have an example here. Give me a second. Text file. Okay, for example, let's create a function that returns call to db um, to books db. And this will return a new promise, and without this say timeout, return new promise. Well, the we yeah, I need to add um, groups.txt here, and well, what's happening here? It's this is another function that will be well. Let me check something pretty quick if I need anything else. Okay, no, I will mock this. Don't worry. Set timeout, resolve books fetched. Right. So what I want to do here, or what I wanted to do in the best case, was read a file and return the values of that, like in a DB. But in this case, I will need to create a whole file system and whatever. What it's easier, remember, set timeout. It's the easier way to mock an asynchronous thing that it's happening, because we can say even the time that needs to happen before that. But actually, time doesn't matter. We can change it to 200, 300, 3000. I'm going to leave it that way. Even if I just say 1 millisecond, because remember, it doesn't matter if this is a very, 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 very fast function. The JavaScript, it's not going to say, okay, if you happen after less than 10 milliseconds, then I will think you're synchronous. No. Not even that. Synchronous code sometimes take much time, more time. Um, what is happening here? It's treated differently since it is asynchronous code, right? So this is going to resolve in 1 second. The books are fetched, and I'm going to leave this reject, but we're not going to talk about that yet. Just give me a second, and I will we will explain. Then we call this function call books to be. What needs to be done, it's dot then and the callback function here. The callback function can be the way we were mentioning, and in this case, function callback function receives the data, console log the data, right? Let's do the sync. Nice, books fetched. Again, despite this was resolved in 1 millisecond, the last thing to be called was this. I will add a console log here to say this is going to be the end. But this needs to be the end, right? But it isn't. Again, we have a start. This is going to be print first, the promise, then end, and then all asynchronous code. Well, it started raining really heavily here where I'm at, so I hope internet connection is still going that well. But again, just let me know if anything's it's failing. I'm going to remove this since it doesn't make sense anymore. And again, this. And since we understand this about promises and how we can resolve them or wait for the callback function after they're resolved, I'm going to delete this other example. So, callback function, sorry, the call or the function to call the database returns a promise. This promise have a result scenario. We can create code to promises, but more oftenly, we as web developers are going to be treating code that returns us promises. These API calls, for example, the fetch, the access, etc. And then it's how we expect these to be executed. But same problem as here. If I want to wait until the books are fetched to finish what I'm doing, I have to do another thing, that is chain these functions. Again, I started by doing a very, very good practice of callbacks. The normal way callbacks were chained was this. and this is bad practice. I'm going to start with the regular way we can chain promises. And this goes like this. We get rid of this. We call this again just to check. Yeah, books are fetched. Just then, another then, just then, and now we are in the correct order, right? What happened here? Then it's very descriptive. We can say, for this, we receive a promise. This promise that then will give or will resolve something. This is like the return for function, but for promises. And that will be data. We can call it data. We can call um, books or whatever. Like it's up to us. And here, for example, we can add something else that is console log of this and then return another a message from the first then, right? And this then will have the message that it's being returned for the first then. In this will be console logging the message. But in this case, I don't want this to return anything. And we can run this again. So we have start, which is at the very first start of our program. The books fetch, because this is the first then we are indicating. Then the message from the first then, because we're returning this. And same as here, we can return in every then, in every then, in every then. But in this case, I don't want. I just want to put some code here. Think the console log as any code you want, right? So put some code here, and it can be large, it could be small, whatever. And after that, I add another then to say this is the finish of our code. So promises really helps to handle this chaining. This looks way better than even this, right? But again, don't think callbacks are bad because even here we are using callbacks. This is a callback. So we are increasing complexity in our code. We need the previous things we learned. Even in this other example where I used let instead of bar, for example, and an error was thrown, and I say to you, "Oh, I'm sorry, I need to change this to bar because I need in this case, in this specific case, I needed the hoisting." Um, but yeah, this is how it works. And before we continue to the async await, I will show you this reject. Hmm. And without removing any of the code, I'm just going to, okay, this callback function is going to receive a parameter now. This parameter will be, I don't know how to call it. Um, let's think, password. So inside of code logic, we do some calls to the database, blah blah blah. And for that, we should need a password. Let's think that if the password is not, but the password we declared, in this case, password will be Alberto 123. Well, if that happened, we are going to reject this call to the to the database, right? So if the password is correct, we say, okay, books are fetched, here's the result. If the password is incorrect, we can say rejection, invalid password. And how we handle this rejection? We can add something that is a catch, and the catch will receive the error and console log the error. So we are going to call this call to the books to the database with the string Alberto 123, right? So if we run this, we receive the same message as in previous examples. But let's say it's Alberto without capital letter 123. So it says invalid password and nothing else happened. This is so great, right? Um, And there's ways to do this with callback functions, with the flow control statements. We saw part three. Now I remember we saw that too. But this really, really makes things simpler. And I'm going to comment this and pass to the async await functions. But first, I need a little break. So I'll be back in less than 5 minutes. Just give me that. Be back. Hey, I'm back. Sorry. And well, I was forgetting something about this. I want you to think of an example like this one. Even if there was an error, we have start and invalid password, which was the error message here. Even with that, we can return a message from the error and then catch it. And in this, then, we could do more async stuff. We can return here another promise and we can catch errors again and changing them and changing them and changing them. But this is not the best scenario for everything. That's why something were added not that recently. It has its time, um, that it's async await statements. So same, let's create, well, let's start with the statement async, that it will be declared before a function that will be async. And same example, we are going to comment all of this. Async function, this suggestion, it's fetch books. And well, um, well, before the try catch statement, let's do just a simple example, that it's const books will receive a call to the API promise we were giving here. The difference is that we are not going to chain the promise with this then. We are going to add a call like this. And we are going to console log these books. Okay, what happened? It's that I didn't even call these fetch books, right? This might look hard to get because we have already declared this function that returned the the promise, but we can also do something like this. Uh, promise, well, the same as this, return your promise. Let books equal async new promise async return async, and then this. here? I'm missing a comma. No. Okay, return. Hello, hello. I'm doing a mess. um, okay, let me debug this. This is this, so that's fine. One comma is expected. Set timeout. Okay, this is fine too. This is not that fine. This is from the return. Quick. Okay, I will accept that. I don't know what changed, but there is no error now, so I think I think Copilot fixed it. Console logs, async function books. If password is not defined, oh yeah, password password promise pending, right? So well, what I mean here, this other way it worked completely fine. Um, what I want to mean here, it's again, it is using the knowledge we've been developing. So first we explain callbacks. We know where when to use callbacks and why callbacks can be dangerous and can be something very messy. Then we explain these promises. We explain the benefits of these promises, but we understand that callbacks are used here because they are necessary. We are making our code complex, and now we understand the promises. We know how to resolve them, how to reject them. But saying this, if we receive a, a, a promise, we can call this promise and add the await um, sentence declaration at this reserved word in companion with the async one. So we say async for the function, we await this call for the the promise, and we store it once it's fulfilled here on the console log. And the big difference from all of these pieces of code that we were checking about the how the async code is removed from the timeline and placed at last, and how we need to change then, for example, these messages. It's this console.log end, and you will see books were fetched. Start and books were fetched. So if we add this here inside the the await call, or even more, do the await here. without storing in any value. Let's see what happened. Start, books were fetched, end. And here, using this await reserved word, we don't need to tell then do this or then do this or put the end inside another callback or something like that. No, in this case, we can combine the asynchronous code with regular code we were writing and just re- return to think if this is displayed first, sorry, if this is declared first, this will be displayed first, right? Let's call this again, but with a wrong password. What's happening? We handle promise rejection, but how we can handle this promise rejection? In the promises, we learned that, for example, this then um, was for fulfillment, and we had a catch. Well, same thing can be done here, just changing the then. And for example, here we can add a try and a catch for the error. So we can put all of this here inside the try. And let's copy this code was for previous part and re- delete all of this. We can delete this now and run this again. Works as fine as this should be, but let's change this and this should fail. Start invalid password and return. Oh, okay, this is the problem. I don't need to return anything, just the console log. Invalid password and the end. And this looks more like regular code that we are used to write, right? So the addition of async await, it's great. And if you ask me, they have great names. I mean, the people doing this really know how to name these things to be easy to understand because callback, it means like call me back when you're done. Promise, I promise to do this. Then when it's done, you can do this. Catch the error. Well, async for telling advising JavaScript this is going to be async. Wait, wait for me. Wait until this promise is fulfilled so we can continue to do all the things you want and try to do this and catch the error if there is any error. After that, we can go along. And the rest of the session, it's going to be for something really beautiful that is the event loop. And since this is a really complicated topic, I'm going to be using this page that you can find too This is not secure. I have to warn you, so I will not share the link. But if you Google, like, just that way, JavaScript B event loop visualizer, it's this one, loop. This video is also great. I tried to use her visualizer, but I couldn't find it. Um, this one, it's beautiful, right? Like with the color gradients and stuff. Um, but I couldn't find a page that do that. So we're going to use this. Actually, there are instructions the first time you open the page. Intro, loop, it's a little visualization. Oh, and this it's magnificent. Like this, I will share because this video, no, this video, it's really the best explanation of what the Apple Loop I ever heard. The name is Phil Roberts. What's the Apple Loop? And the page was for a JSConf. So let me share this link. I will recommend you to take a look to this magnificent video. And well, little visualization to understand how JavaScript call stack, heaven loop, callback, create, interact with each other. The best thing to do to understand how this works is to watch this video. I completely agree. Then, when you're ready, go play. Instructions: write some code in the text editor on the left, hit save and run button, and watch it run. You can create HTML elements in the gray box at the bottom left by hitting the edit button. Listen for dumb events on them with the click me like this, and hit the icon at the top left bottom for settings. How this works: loop runs in your browser, takes your code, routes through Schema, IAS parser, blah blah blah. Okay. Phil Roberts, it's this person. So again, I really recommend you to watch this. So let's go ahead. Let's go play. First, let's show what this is. Okay, now I understand the example. Um, I am going to add a code console.log and start. And first, let's explain what a call stack is. The this difference between queues and stacks, um, it's really simple. I don't have nothing at the hand, but I'm going to use fingers. I think the acronyms for this it's FIFO. In a queue, first in, first out. Meaning, when you make a queue, uh, for example, if you go shopping or you are waiting for the ATM or you go to the bathroom or in any line, any queue you may know, um, it's first in, first out. That means if you enter first, you are going to go out first. So it goes this and this and this and this. So imagine these four people are in line, um, waiting for the bathroom. The first people going out the line, meaning entering the bathroom, it's the first who arrived. That's a simpler, that's a queue. And a stack, it's different. It's the last in, it's the first out. And the best example for this are dishes, I think. We imagine that you have a stack of dishes and you are going to wash them. You start collecting them and you put the first you collect at the bottom, and over that you put the other, the second, and over that the third, and over that the fourth, and in that way. But is the first one that you collect the first one to be washed? If it is in your case, you're a weird person, because what I sing and I do, and I think normal persons do, normal people do. It's you have your stack, you put it just by the side of your dishwasher or your wherever you wash your dishes, and you take the first on the top, and that's it. The last that you collected, the first in, it's the last to go out. The last in the stack, it's the first to go out. So again, you take your first plate and you place the second plate inside the sorry, over the first plate, and the third over the second, and the fourth over the third, and the fifth over the fourth, and the first you're taking out, it's the very one at the top of all the dishes. And you start removing this, and you start removing this, and you start removing this, and before you wash the first that you collected, you put another one, and then your any of your siblings arrive and tell you like, "Oh, I finished late. Here's another dish," and pour off the first dish that you collected. Again, it is going to have to wait until everything that is on top gets done. That's the call stack, the callback queue. And the web APIs refers to what it's happening there, whatever it's asynchronous. I don't know that the web API it's the best name. Let me look if I can find something that calls this differently. No, yeah, they call them the web APIs. Okay. Well, I found someone calling this the. Ooh, this is beautiful. I found another great example. Call stack, even queue, the event loop. Okay, this is the event loop. The here it doesn't have name, but let's run this to understand what's happening. Maybe we have to run this many times, but don't worry. The first thing to happen is that we are going to run the console log, right? So this is highlighted. This goes inside our call stack. I sorry, I had to add a lot of this. What goes inside our call stack says, sorry, I was just watching the animation. What goes inside of call stack is what it's going to happen in our code. Same as this. For example, we have the console log. The console log it's going to be fulfilled very quickly. Then what happened? We have a query to the database. The query to the database is going to be asynchronous code, web APIs, however you want to call it. It's going to be out of our scope. And remember, I told you JavaScript first is going to complete all synchronous code, that meaning all the call stack. Then, after the resolve of or return of the asynchronous code it's going to be stored in the event queue. For example, we set many timeouts. Some of them resolved immediately in 1 millisecond. When we create promises, that's still asynchronous code. Even though it was resolved very quickly, it goes outside our call stack. We complete our call stack, and the event loop is going to decide or add things from our event queue to the call stack again. Now they can be resolved. For example, here, and this is very similar to what we were doing. The first thing to happen is starting Node.js. The console log happened and the output starts here. Then we have a, um, a query, and this query goes to the web APIs or asynchronous code section, however you want to call it. Again, I think it is not necessary uh, as a web API, and many asynchronous code can be called. But here it is very demonstrative. We receive the return for that asynchronous code, and it is stored in our event queue. Event queue even resolve that. We know that the query is executed. We know that, but before passing it to the call stack, first we need the event loop to decide, okay, we're done. We're ready to add it to the call stack. So that's, for example, the same thing here. That's this explains why even this console log was called first, this second, and this third, this was displayed first because this query executed needed to wait until the call stack was empty to the event loop pass it to the call stack. Let me see if they have a more complex. No, no more complex examples of this animation. But this is a set timeout, right? Okay, I need to refresh this completely. Okay, close. Save this. Again, code. Let me see. Nice. Yes. So this writes on the console. So we have our start first. Let me refresh this. Rerun. Console was called. Immediately it was called. So then we add a listener for the click me that can be considered as a web API, but nothing is displayed. Then we have our console log, again, immediately added to the console. Then we have a set timeout function that says click the button. And last, We have the sorry, no. This set timeout, since it's asynchronous, was passed to the web APIs. Then it was passed to the callback queue. But before that was displayed on console, we needed to display the welcome to loop. So check out. There are three console logs that are not asynchronous code, meaning this is going to be displayed first, this is going to be displayed second, and this is going to be displayed third. Start, hi, welcome to loop. So we have two asynchronous code happening here. The first one, it's a regular set timeout that after 5 seconds of execution, it tells us this is going to happen. So that's why this is already displayed. Click the button. And if we click the button, the listener told us that what's happening is that another timeout is going to be triggered, and this is going to wait 2 seconds after a console log will be displayed um, saying sorry, you clicked the button. But we can do another thing before this, that it's console.log, even not before, after, between quotes, this execution, we can add this is going to be displayed first on click. Let's save and run this. Let's wait for that to fulfill. The web APIs tell us this is happening. This was added to the call stack. Now it's empty, and now we're ready to go. If we click this, we have to wait until this was fulfilled. And again, click the button was the instruction of the first timeout. Then when we click it, a set timeout, another asynchronous code was called, meaning it has to go through the web API or the asynchronous code section, wait to be fulfilled, then pass it to the queue, and then can be added to the call stack. If we had nothing to our call stack, then that can be displayed. But we have something that is this console log I added, which is this is going to be added to be displayed first on click, and that were true. This was displayed first on the click, then the message inside the say timeout. Let's finish this session putting this. A functional callback to these DBs, to these books. And inside the button of the click, let's do another thing that is an async function on click and await. Sorry. Um, let's copy all of this. Well, without the try. And without this timeout. Okay, let's save and run this. So we have the start, the hi, and the welcome to loop, right? After the timeout is done, we will have the click the button. We have to click the button. Now I'm going to add the click me. And this time, I want no what happened. This is not showing my code. I added. Okay. Yeah, this is the code. The code I added. Async function on click expected and okay on click async. Am I writing this async? Yeah, it's correctly spelled async function. This will be the first thing to happen there. Console.log, then the try, then the catch, and we can finish this. And I don't know what this is happening. Okay, this is not respecting my code. Um, I don't know why. I don't know why. Pause, edit. Okay, let me close the this. Mm, okay, maybe we cannot edit it that much. Even tried to be honest. But with this scenario, just with listening to say timeout and knowing that synchronous code and knowing, for example, why this is happening first and this other later, that it's the graphic. The last thing that I wanted to share with you and the graphic way to describe this asynchronicity in JavaScript, the callbacks, the promises, the async await events. So that will close the event loop. Again, watch the video I shared with you. Really, that's beautiful. That's amazing. If you want to learn more about JavaScript, let me know. I will be so glad to share whatever I can share with you on these Global Hack Weeks. And well, I would like to answer some questions if you have any. If not, I think we can wrap up this series of 4 sessions talking about JavaScript. I know we don't cover all. JavaScript it's so immense. JavaScript it's so beautiful, but again, check the links I share with you. Check the video for the Evan Loop. Check Eloquent JavaScript, which is a great book and it's free, completely free if you want to check it online. Check if you have the money. Just JavaScript, which is the course of Adam Abramov, that is beautiful. Again, I really recommend that. Um, and what else? Mozilla for the JavaScript documentation. Free Code Camp have great resources for learning JavaScript. And I just have to say that the best thing to learn something is to practice and to teach it. So uh, I encourage you to start JavaScript study sessions or your campuses on your local community. That's what I did, to be honest, and I don't regret it. I completely loved it. I enjoyed it a lot, and I learned a lot of things. Um, so I'll give you some minutes to comment here any questions you may have. If not, just tell me what you think about these sessions. If this was your first, what do you think about this? Or if you were watching um, the full series, well, let me know. I'm out of water. Meanwhile, I'm going to put this on a no on a Git repository and share the links with you. Give me a second, and I'll do that. Developer Git. Global Hack Week. See some launch. Yes. Public choose license. No query repository. Okay, so let's do this. Git init, git add, git commit all uh, all we work on git remote add git push and you origin name. Okay, I think it should be it now. This is the link to the repository. If this helps you in anything, well, here it is. Well, I just see a Sky comment saying thank you. Well, that's all. Thank you a lot. Sorry for joining me, and I hope to see you back. This was my last session for this Global Hack Week, and I think we still have one more session coming up. Let me check. Yeah, IoT Intro to IoT Part 3 from Read B at well, I think it's starting just now after this session is done. And then we have the closing ceremony tomorrow, 12 a.m. No, 12 p.m. ET time. Well, the 0 and the 12 think it's kind of confusing sometimes, but let's say 12 ET time. Thank you so much also for staying here, Sparky's Recruit students, Kai, and all the great hackers, Zlian 55, um, Gamlendra. So, best, take care, and happy hacking. See you next Global Hack Week. Bye.